So this is a Bob Prosperi projection. Last year when he saw me post something on the HHC website, museum website, he said, "Oh, it looks like a presentation in the works." Well, it wasn't quite ready last year, so this year we come up with something. So I think the DM42 is just a great calculator. It's not only a great calculator, but it's a amazing display. So I thought I'd give a talk on a little bit about the display, and really about the basics of how to do some graphics. So what this presentation is today is just an idea of how to get some basic graphics on it, what the capabilities of it, what the resolution is, and just how to do some basic things in programming, and then show some little more graphic things like Mandelbrot plots and some things in that order. So, graphics on the DM42. Why are graphics of interest? So, has a 400 by 240 pixel display. You do characters from different sizes with custom scripts. It's fast, and even faster with the USB plugged in, as we know. And then you can do amazing 2D graphs with the DM42. So here's the fundamental display itself. It's a screen size of 68.6 millimeters. It's, as I said, 400 by 240 pixels. And then there's a control. The control is done by the GR mod control under from Swiss Micros. So there's the standard resolution, which is the 131 by 16. That's the default mode, and that's the same thing as on the 42S. Then there's a 200 by 120 for if you set that at a 2 and you store it with GR mod, or you can go up to the full 400 by 240 with a setting at 3.
Do people use that display to artificially create text on it?
Yes, yep, you're going to see that. So there are some fonts, and we'll talk a little bit about generating and storing fonts, and then we'll talk about flags that affect the display and some commands. So, whoops, I went backwards, sorry about that. So there's a couple of flags that affect, flag 34 and 35 are the A-graph control, and you can see the different things that affect it. They're both default clear, or the image is merged with the existing display, which is logical or you can do a clear set, which image overwrites all pixels in that portion of the display. You can do a set clear, which duplicate on pixels get turned off, or then set, which pixels are reversed, or logical XOR. So there's some helpful programs that I found on the web, and we're gonna go through some of these today. And couple of these I wrote, and then a few I'll give credit to those that I found some of the displays. So this is just a simple Pi program, and there was Bill from Smithville in New Jersey wrote this, and all it does is it just simply displays Pi in different locations on the display. And this is just a screen print, so you can do a shift display, and this will do a copy of a bitmap to your DM42. So that's just where that came from.
Was that 14 or 15?
2, 4, 6, 8, 10, 12, 13, 15. So, and all this does is it just moves the decimal place 1 for each loop into it. It's pretty simple, but just shows you can position different things. It's using a display, a font that's loaded into the, not only a font, but also a display program. So there's a font program, there's a display program. So it's created a font for this, and then it's also got a display program which can manipulate where on the screen it's going to display. And I'm not going to go into detail on this. If you've got some interest, I can send you a link to those areas to go look for those.
So these are 5 by 7 dot numbers?
We'll go through that.
Okay.
So these are big characters versus small characters, and just shows the capability of doing uppercase big and small uppercase. And these are just different fonts created. You can do lowercase big and lowercase small, and as well as big number symbols and smaller symbols.
Lowercase small looks a
Yeah,
lot.
that looks like a
Yeah.
lot like capitals, doesn't it? I just noticed that as well. They should have put that in the lowercase.
Well, there's fewer dots available.
So you can do subscripts and superscripts. So really nice for creating programs where you can actually write formulas on the display. And this is just a program called S2 that I pulled off one of the websites. So here's some commands. The LCD clears the whole display. So once you want to start with a blank display, you probably want to call that. CLA clears the alpha register, CLD clears the display. A-graph displays a graphic image. Each character in the alpha register specifies an 8-bit column pattern. I'll show you in detail kind of how that works. Pixel turns on exactly 1 pixel in the display at the location XY. A-store copies the first 6 characters in the alpha register. You got A-view, and then grmod is a DM42 command that sets the display resolution. And then resx and resy are read-only values, and they basically tells for that setting what's the current resolution set in the registers, just in case you want to go back and query it. So here's graphics on the DM42 for creating an alpha string for a graph. So you're actually creating a vertical dot pattern. So you've got 7 dots and 8 dots, and that ends up being a column print number of 99. So if you're creating a font, you'd end up creating a graphic, and this is just a happy face. So if you can see it kind of created in there, and so basically you have to go through and create each of these column numbers and then load them into a graphics spot inside the DM42. So this is a program of how to do a smile program, and he just shows the program, shows the X to A, loading it into the alpha register, and it's appending these, and then it specifies the location. So the 562 is locating it into where it's going to print it, and then it does a CLCD. And so what I've done is I just wrote this, and then I wrote a little loop on there. So when you go up here, hopefully I can get this to work.
Oh, my machine is not.
All right, here we are. So always like, I took this from Jeff. Jeff always likes to put his fingers in his graphics. So as you see what this does, it takes the graphic, it stored it, and now it's just got a random program that just randomly moves it around the screen.
That just makes you smile.
I think it's just kind of a nice, fun thing, right? You know, you just kind of look at this and just kind of be happy, and
You should start singing that song. Be happy.
it uses the random function inside the DM42. So I'm always wondering, why isn't filling in this space over here?
Is it the same space, same area?
It just seems like an area that just doesn't get filled.
Well, that's a good test for randomness right there.
It is. Richard would know about this, right? All right, so let's go on to the next one. So we've done a smiley face. We're going to draw just a simple line. Let's just draw a line of pixels across the screen. And the graph. So there's a program to do that. And all we're doing is just executing a line. We tell it length. So it's just doing a menu. It's got length, it's got X. Where's the X and Y starting? And hit execute, and boom. You get a straight line. Pretty simple, right? So where do we go from here? Well, of course, a circle. Here's a program to draw a circle, and I just set it for the medium resolutions, the 200 by 120. same thing. There's a menu that comes up, and what's the radius, and then where's the center for the X and Y. So I've entered radius of 50, it's 100, put the radius at about the center, 60.
It's 50 pixels?
It's, yeah, correct. So, there we go,
Wow.
a circle. Pretty simple. So then I thought, well, we got smiley faces, we got lines, and we got circles. Let's put the smiley faces inside the circle. So that's a good exercise. Huh? So let's try that. So I did this last night at midnight, taking this with my handheld iPhone, so you're going to see a little bit of a jitter. So it draws a circle, and only put smiley faces inside the circle.
And
There's one little bit outside, but there's I think this top of the smiley face is really where the origin is on the smiley faces. So, as you can see, from 10 hours of flying, I had a little bit of jitter going on. I didn't have my USB camera where I could.
you can just see the guy with the smiley face bullet standing 20 feet behind the screen.
That's right. That's right. So that was kind of fun. I brought that on the way out on the plane. So I didn't put a video up of this, but a guy named Wawa Chief in Normandy, France, did a really great Sudoku program. And on the screen, it draws all of these. It draws the lines, it draws the grids, it draws the subgrids. It's really beautiful. And then you can go in and fill it. And he has a solver program that will go in and solve it too for you. So it checks it and it'll solve it. But it's really a nice, beautiful use of the screen. And I thought it was a really good demonstration to show, what it can do. So this was just a screen print that I took off the
Now,
screen.
what's the requirements for, you arrange the remaining numbers, but is there some sort of guideline you use? Is they have to sum up or something?
Yeah.
I'm not familiar with it.
And I'm not a Sudoku fan, so I'll let the Sudoku fans in here, but they've got there's a sum, the way you sum them up, you only use one number per grid, per 9 grid, so it's got to be 1 through 9. They can't repeat inside the grid.
Yeah, each row and column has to have.
Yeah, each row and column is
And also all the ones in a smaller square, 3x3 square have to have a different number.
Right, correct, yep. So this guy, I think it's about an 800 line program when he's finished. He did quite a bit of work on this. It's pretty neat. So here's a plot, a nice plot that's done, and I didn't do a screenshot, right? This is just a screenshot, but this is what you're capable of, in some of the programs that they've got running. This is a program called D3 Plot, and here are the input parameters. There's 2 programs, different programs that run the D3 CFG, and then there's a D3 Plot that'll plot this out. And you can put different parameters in there, and it'll give you different resolutions and different capabilities of it. So this is a nested polygon program, and I did do this one. I think this was pretty cool. So you can run it, and it'll have comes up with a menu that says how many sides, and I chose 4 sides because it's kind of simple to watch it. N is how many polygons you're going to draw, and then mu is a kind of a value that's put in that kind of gives the resolution of it. So again, it just shows the capability of the DM42. It has a lot of capabilities to it, a lot of ability to draw really complex type of things. Mandelbrot plots take about, depending on what resolution you set it for, and whether you've got the USB plugged in or not, which you definitely want it plugged in, it could probably take anywhere from a half hour to over an hour to run. So this is just a picture of one of the ones that somebody done, but I've got another one on here that I ran, and that took about an hour to run that one. So nice plotting capability, and again, good resolution, good screen resolution. So this is just a screenshot of it. it looks actually a little bit nicer on the calculator itself. So really, that's the summary of my presentation. You know, the goal of this paper to share some of the graphics capabilities. We started with the basics of understanding of just doing simple graphics with a smiley face and a line and a circle, and then shows how you can combine, you know, graphics together with the circles and lines. Show different display resolutions, demystifying the drawing of lines, and there's some program examples in there that show that. And then finally build on the legacy of the HP42 calculator, Thomas Ocken's open source pre-42 code, and you know, just have fun. It's a great calculator, has a lot of capabilities, the display makes it amazing, and we've seen there's already springboards of new calculators coming out with that. Here's some credits and acknowledgments. Certainly the Thomas Ocken, we owe a great deal of help to him. There's some programs that I used in this demonstration, and you can go search for them, and you'll find those easily on the web. And thanks a lot. Appreciate your time. Is it grayscale?
That was my question.
No,
No.
only by dithering.
Yeah. Yes.
So there were 3 resolutions, so the 16 high is the original 42.
Yes.
What's the middle one for that? Or just because they could?
It's just because it could. Yeah. Yeah. There's a. Yeah, it's just a mid resolution, you know, capability, and then you've got the full screen resolution of 400 by 240. Oh, thank you. Yes. Yes. Yes, Jim.
I noticed there was a pix on command. Is there one for pix off?
Yes, it's a, yeah, I think you have to set it on the, depending on what the flag you set, you can reverse or it and turn it on.